According to the 2020 National Electrical Code, GFCI, which stands for Ground Fault Circuit Interrupter Protection, is required for certain types of electrical outlets located in areas where there is a risk of electrical shock due to moisture or water presence. These areas include bathrooms, kitchens, garages, and outdoor outlets. The NEC specifically requires GFCI protection for outlets serving equipment in wet locations such as laundry rooms. However, it does not explicitly mention washing machines or their circuits. The 2005 NEC did not have specific requirements for GFCI protection of washing machine circuits. However, the 2020 NEC clarified and expanded GFCI protection requirements, including extending protection to all outlets in laundry rooms. An electrical inspector may have been referring to an updated interpretation or local code amendment that requires GFCI protection for washing machine circuits. It is recommended to contact the local authority having jurisdiction, or OJ, or electrical inspector for clarification. The following NEC articles support the requirement for GFCI protection in laundry rooms. Firstly, 210.8, which requires GFCI protection for outlets in laundry areas. Secondly, 550.12b, which requires GFCI protection for outlets in bathrooms. And thirdly, 550.13b, which requires GFCI protection for outlets in kitchens. There are some exceptions to the GFCI protection requirement for laundry rooms. These exceptions include: firstly, permanently connected appliances such as gas dryers; secondly, circuits dedicated to appliances with GFCI built in; and thirdly, outlets located more than 6 feet from the edge of a sink. While the 2020 NEC does not explicitly require GFCI protection for washing machine circuits, it does require GFCI protection for outlets in laundry rooms. It is possible that an inspector was referring to an updated interpretation or local code amendment that extends protection to washing machine circuits. To obtain accurate information, it is best to consult with the local authority having jurisdiction or electrical inspector. It is important to understand the nuances of electrical codes and their interpretations to ensure safe and compliant installations. Ground fault circuit interrupters are designed to protect individuals from electrical shock by monitoring the current flowing through a circuit. If there is an imbalance in the current, indicating a leakage to ground, the GFCI quickly trips the circuit, cutting off power and preventing potential injury. This is particularly crucial in areas where water is present, as water can significantly increase the risk of electrical shock. When dealing with electrical inspections and code compliance, always refer to the most current edition of the NEC and any local amendments that may be in place. Local amendments can vary depending on the jurisdiction and may impose stricter requirements than the NEC itself. To clarify any ambiguities or discrepancies, reach out to the local AHJ or electrical inspector for guidance. They can provide insights into the specific interpretations and enforcement practices in the area. In the context of washing machine circuits, it is important to consider the potential for water exposure and the risk of electrical shock. While the NEC may not explicitly mandate GFCI protection for the washing machine itself, the requirement for GFCI protection in laundry rooms effectively addresses this risk. By ensuring that all outlets in the laundry room are GFCI protected, any potential fault current from the washing machine or other appliances will be detected and interrupted, preventing potential harm. When installing or modifying electrical circuits, always follow safe electrical practices and consult with a qualified electrician if you are unsure about any aspect of the work. Electrical work can be dangerous if not performed correctly, and it is essential to prioritize safety at all times. This includes using appropriate tools and equipment, following proper wiring techniques, and ensuring that all connections are secure. Grounding is another critical aspect of electrical safety. A properly grounded electrical system provides a low resistance path for fault current to flow back to the source, allowing the overcurrent protection device, circuit breaker, or fuse to trip and clear the fault. This helps to prevent electrical shock and minimize the risk of fire. Ensure that all electrical outlets and equipment are properly grounded in accordance with the NEC and local codes. Regular inspection and maintenance of electrical systems are also essential for ensuring continued safety. Check for any signs of damage or wear, such as cracked or frayed wires, loose connections, or malfunctioning outlets. If any issues are detected, have them repaired promptly by a qualified electrician. Remember that electrical codes and safety standards are constantly evolving to address new technologies and emerging risks. Staying up to date with the latest requirements is crucial for ensuring safe and compliant electrical installations. Take advantage of training opportunities and resources provided by industry organizations and regulatory agencies to enhance your knowledge and skills. In summary, while the 2020 NEC may not explicitly require GFCI protection for washing machine circuits, the requirement for GFCI protection in laundry rooms effectively addresses the potential for water exposure and the risk of electrical shock. Always consult with a local authority having jurisdiction or electrical inspector for clarification on specific code interpretations and enforcement practices in your area. Prioritize electrical safety at all times and follow safe electrical practices when installing or modifying electrical circuits. Electrical safety should always be a top priority when dealing with any electrical work. It's not just about adhering to codes and regulations, but also about protecting yourself, your family, and your property from potential hazards. Ground fault circuit interrupters are a vital component of modern electrical safety systems. They are designed to detect even the smallest imbalances in electrical current, which can indicate a ground fault. A ground fault occurs where electricity deviates from its intended path and instead flows through an unintended conductor, such as a person's body. This can result in a severe electrical shock or even electrocution. GFCIs work by constantly monitoring the current flowing into and out of a circuit. If there is a difference of as little as 5 milliamps, the GFCI will trip and quickly cut off power to the circuit, preventing a potentially dangerous situation. This rapid response time is crucial in minimizing the risk of injury. GFCIs are particularly important in areas where water is present, such as bathrooms, kitchens, laundry rooms, and outdoor locations. Water is an excellent conductor of electricity, and even small amounts of moisture can significantly increase the risk of electrical shock. By installing GFCIs in these areas, you can greatly reduce the likelihood of electrical accidents. In addition to GFCIs, arc fault circuit interrupters, or AFCIs, are another important safety device that can help prevent electrical fires. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can occur when wires become damaged or insulation breaks down. Arc faults can generate intense heat and can quickly ignite nearby combustible materials, leading to a fire. AFCIs work by monitoring the electrical current for unusual patterns that indicate an arc fault. If an arc fault is detected, the AFCI will trip and cut off power to the circuit, preventing a fire from starting. AFCIs are typically required in bedrooms and other areas where people sleep, as these are the areas where fires are most likely to occur. When it comes to electrical safety, it's always better to be proactive rather than reactive. Regular inspection and maintenance of your electrical system can help identify potential problems before they become serious hazards. Check for any signs of damage or wear, such as cracked or frayed wires, loose connections, or malfunctioning outlets. If you notice any of these issues, have them repaired promptly by a qualified electrician. It's also important to avoid overloading electrical circuits. Overloading can occur when you plug too many appliances or devices into a single circuit, causing it to overheat. This can lead to a fire or other electrical problems. To prevent overloading, use power strips with built-in circuit breakers and avoid using extension cords as a permanent solution. When working with electricity, always follow safe practices. Turn off the power to the circuit before working on it, and use insulated tools to avoid electrical shock. If you're not comfortable working with electricity, hire a qualified electrician to do the job for you. Remember, electrical safety is everyone's responsibility. By taking the necessary precautions and following safe practices, you can help protect yourself and your loved ones from the dangers of electricity. Consider hiring a qualified electrical contractor to inspect your home's electrical system. A licensed professional can identify potential hazards, ensure compliance with current codes, and recommend necessary upgrades or repairs. This proactive approach can significantly reduce the risk of electrical fires and shocks, providing peace of mind and a safer living environment. Another aspect to consider is surge protection. Power surges can damage sensitive electronic equipment such as computers, televisions, and appliances. A surge protector can help protect your devices by diverting excess voltage away from them. Whole house surge protectors offer comprehensive protection for your entire electrical system, while individual surge protectors can be used for specific devices. When selecting surge protectors, look for models with a high surge current rating and a low clamping voltage. These features indicate that the surge protector can effectively handle large surges and minimize the risk of damage to your equipment. Regular testing of GFCIs is essential to ensure they're functioning correctly. Most GFCIs have a test button that you can press to simulate a ground fault. When you press the test button, the GFCI should trip and cut off power to the circuit. If the GFCI doesn't trip, it may be faulty and need to be replaced. It's recommended to test GFCIs at least once a month to ensure they are working properly. When replacing electrical outlets or switches, always use the correct type of device for the application. For example, in areas where moisture is present, use weather-resistant outlets and switches. These devices are designed to withstand exposure to water and other elements, reducing the risk of electrical shock. Also, be sure to use tamper-resistant outlets in homes with young children. These outlets have a built-in shutter mechanism that prevents children from inserting objects into the slots. Proper grounding is critical for electrical safety. A properly grounded electrical system provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protection device circuit breaker or fuse to trip and clear the fault. This helps to prevent electrical shock and minimize the risk of fire. Ensure that all electrical outlets and equipment are properly grounded in accordance with the NEC and local codes. If you have any concerns about the grounding of your electrical system, consult with a qualified electrician. Use appropriate wiring methods for different applications. The NEC specifies different wiring methods for various types of installations. For example, in damp or wet locations, use moisture-resistant wiring such as type UF cable. When running wires through walls or ceilings, protect them from damage by using conduit or other approved methods. Following proper wiring methods can help prevent electrical problems and ensure the safety of your electrical system. Be aware of the dangers of overhead power lines. Keep ladders, antennas, and other objects away from overhead power lines to avoid electrical shock. If you're working near overhead power lines, maintain a safe distance and be aware of your surroundings. Contact your local utility company if you have any concerns about the safety of overhead power lines. Educate yourself and your family about electrical safety. Teach children about the dangers of electricity and how to avoid electrical hazards. Make sure everyone in your household knows how to respond in an electrical emergency. By promoting electrical safety awareness, you can help prevent electrical accidents and protect your loved ones. In addition to GFCIs and FCIs, smoke detectors are another essential safety device that can help protect your home from fire. Smoke detectors are designed to detect smoke and alert you to fire, giving you time to escape. Install smoke detectors on every level of your home, including inside and outside of sleeping areas. Test your smoke detectors regularly and replace the batteries at least once a year. By taking these simple steps, you can greatly reduce the risk of fire and ensure the safety of your family. Remember, electrical safety is an ongoing process. By staying informed, following safe practices, and maintaining your electrical system, you can help protect yourself and your loved ones from the dangers of electricity.